Okay, so continuing with the using formulas with decimals activities from class, I'm going to do pages 3 and 4. We had done number 8 as a class, but I will again just go over it right now in the video. So for number 5, I've got this formula where A is the ending balance after Y years, P is the starting amount, APR is the annual percentage rate as a decimal. And they tell us we want to know the ending balance after 10 years. If we start with 20,000, and we know our interest rate is 0.08. So I'm going to go ahead and just write all the things down that I'm going to have to plug. So y equals 10. The starting balance, that was the p, so p equals 20,000. And the APR is 0.08. So plugging that into the formula, I get a equals 20,000 times 1 plus 0.08, and then I'm plugging in 10 for the y, so that's actually an exponent. When you're simplifying this, be careful to show each step. So use your order of operations and try not to round anything till the very end, because that will mess up your answer. So my first step is to take care of inside the parentheses. So I got 1.08 to the 10th. My second step is to take care of the exponent. So I'm following PEMDAS here. So parentheses, did that, exponent, so I'm doing that next. So on my calculator, that's 1.08 exponent 10. Okay, that's a crazy decimal. Don't worry though, we can just leave it in our calculator for the next step. So maybe just write down a few digits here, keeps going. Don't hit clear, actually just multiply that by 2,000. That way you don't have to, or 20,000, that way you don't have to write the whole thing back in there. And so I end up with A equals 43178. We'll just round up to 50 cents. 50 cents. So $43,178.50. If they don't say how to round in the problem, when it's money, you usually go to the nearest cent. Otherwise, it's kind of your call on what you think you should round to. Okay, so, they do want complete sentences, of course. So the amount is, and I'm not going to finish that, but you guys can do that. The amount is blah, blah, blah after 10 years. Okay, number 6, I've got another formula, and I'm plugging in, let's see, R is the number of rabbits, N years, find the population after 3 years. Okay, so 3, is that going to go in for the R or for the N? Well, since N is years, we know that it must be N equals 3. So I get R equals 5,000 times 1.23. 3 is the exponent, so I'm plugging it in for N. Okay, so using order of operations, make sure you show your work here. 1.23 exponent 3. I get 5,000 times 1.86. Try not to round it yet. 0.867. And last I'm going to multiply. So exponents and multiply. So I get R, and let's round to the nearest whole number because we don't want parts of rabbits. That's gross. So we've got 9,304 rabbits. And again, write the complete sentence, so that's a lot of rabbits. Alright. So after 3 years, blah, blah, blah. Okay. Number 7, again, a formula. How old should a person be if they maintain a minimum target heart rate of 96 beats per minute? Okay, we need to figure out which variable to put that in for. Looks like we've got X is years old, their age, heart rate is T beats per minute. So 96, is that the X, the years, the age of the person, or is 96 the T, the beats per minute? Well, it must be the T, so I'm plugging in T equals 96. So that gives me 96 equals negative 0.5x plus 120. And looks like I've got to solve an equation, right? So unlike these top 2 problems where I had the variable by itself, here the R was by itself, here the A was by itself, this one actually means I need to do some solving. X is not by itself. So use your inverse operations. First you're going to subtract, from both sides. So we've got 96 minus 120. I've got negative 24 equals negative 0.5x, and then divide both sides by negative 0.5. Alright, we get 48 equals x. So the person should be 48 years old. And that's to have the target heart rate of 96 beats per minute. I'm not going to finish writing that one. You can finish writing that one yourself. So, person should be 48 years old to have a target heart rate of 96 beats per minute. Okay, moving on to number 8. We did this one in class, so I'm going to just do it real quick. Phi is the number of virus cells after D days. N is the initial number. They give us 10 days and initially has 100 cells. So I know D equals 10, N equals 100. So I'm plugging those in. I get V equals 100 times 1.52 to the 10th power. You could also use parentheses on the 1.52, and that would kind of remind you, okay, I need to multiply, or on the 100. So I think we're ready to just use our calculator. Show your work. So 1.52 to the 10th, 65.8318. Yeah, try not to round because we're about to multiply by 100. You just want to wait to do your rounding till the last step. So I get V equals 6583. And now we can round to the nearest cell, so we don't have parts of cells. And that was after 10 days. Okay. Moving on to the next page. Number 9, we've got T hours. We're finding the number of bacteria B. How many bacteria were there after 7 hours? So I've got B equals 100 times 1.5, and my exponent is a 7. So I'm plugging in T equals 7 because T is the time in hours. Again, just use your calculator for this. So 1.5 to the 7th, I get 17.0859 and so on, and then times 100. And we can round to the nearest bacterium. So 170, and the 5 would make the 8 go up to a 9. And again, write your sentence. So after 7 hours, okay, number 10, and we've done a lot of this Fahrenheit to Celsius conversions. This time they're writing it as a decimal. So they want us to find the Fahrenheit temperature that's equivalent to 36.5 degrees Celsius. So I've got C equals 36.5. I'm plugging that in. So normally, when we're solving equations, we would add or subtract first, multiply or divide second. But this equation's slightly different in that it has parentheses in it. And as we know with the order of operations, parentheses is actually something you would do first if it's order of operations. So when we're solving an equation, that means we're going to do our parentheses last. So we're doing reverse order, meaning we got to do this last. So the first thing we want to do is actually take care of the 1.8. And it's showing up as division here. So the inverse of division is multiplication. I'm going to multiply both sides by 1.8. You don't actually multiply on the side that has the 1.8 down there. Those just cancel out, and I get left with f minus 32. On the right side, on the left side, I've got 1.8 times 36.5. So I got 65.7. And now, I guess I didn't write my parentheses again because at this point there's nothing else there except f minus 32. So we don't need to write the parentheses now. And we're able to finish solving for f. So add 32 to both sides. So was that 97.7 equals f. So 97.7 degrees Fahrenheit. That is the same as 36.5 degrees Celsius. Okay, and that's it for this activity.